you that haven't responded, have you done this formula at school, please? I'm just going to ask one more time. Thumbs up for yes, thumbs down for no. Okay. No. Okay. So thank you, Stephanie. Yeah, Nela says no. Okay. So there are, Nolatundo says yes, Trish says yes. Okay. So there are quite a lot of you that have not said yes to this. So the reason that I need to know this is because if you haven't done it at school already, then I don't want to confuse you, and I'm obviously going to go a lot slower. Hopefully you are doing geometric sequences and series as the very first thing, and you've been able to understand what's been going on in our Watobe lessons, our first, our second, and our third lesson. Let's just start with something very simple, all right? When we talk about a geometric sequence is like the one that is on the screen at the moment, okay? So a geometric sequence, okay? So the first term is 3, the second term is 6, the third term is 12, the fourth term is 24. How do I know that this pattern is geometric and not arithmetic? What is my clue that this is geometric and not arithmetic? Can anybody put it in the chat and tell me? How do I know that this pattern is geometric and not arithmetic? Let's have a look what you guys are saying. Okay, so there's no constant difference, fair enough. There's a constant ratio. There's a constant ratio, divide term 2 by term 1. There's a constant ratio. So there's no constant first difference. Absolutely. Absolutely. So we're looking at the difference between the terms, and we can see that the difference between 6 and 3 is not the same as the difference between 12 and 6, is not the difference between 12 and 24. Okay, so when we look at that straight away, our first differences are not the same. Then if we examine the numbers a little bit closer, we begin to see a pattern emerging, all right? As I go from one term to the next, each subsequent term is 2 times bigger than the term that came before it. So 6 is 2 times 3. 12 is 6 times 2. 24 is 12 times 2. All right, so in other words, if I then work out a ratio between the numbers, I see that 6 over 3 is the same as 12 over 6 is the same as 24 over 2. So my constant ratio is R. Oh, sorry, I didn't mean to write R. My constant ratio, sorry, I'm being an honor here. That's supposed to be a 1, is 2 in this instance. Okay. I can also see that the very first term in my pattern is 3. So now the biggest difference between a geometric sequence and a geometric series is that with a geometric series, we are adding our terms together. So when we talk about a geometric series, it is still made up of the sort of numbers that would form a geometric sequence, only these numbers are being added together. So a geometric series using the same terms would be 3 plus 6 plus 12 plus 24. Okay, so what I can do here with this geometric series is I can calculate the sum of my terms. So if I want to look at the sum to the first term, it's going to be the same as term 1 in this case, which is 3. The sum to 2 terms is going to be term 1 plus term 2. That's what it means. So in this case, it's going to be 3 plus 6. So the sum to 2 terms would be 9. If I wanted to calculate the sum to 3 terms, it would be term 1 plus term 2 plus term 3. So that would be 3 plus 6 plus 12. So the sum to 3 terms would be 21. So now I can work out a sum to n number of terms. How is everybody feeling so far? Is this making sense? Thumbs up.
Nice, guys.
Yes,
Remember to take screenshots.
Yeah, take screenshots. It's a great suggestion. Thanks, Yolanda. Yes, Pinga, you can be asked to prove these in exams. Doesn't come up very often, but your teacher should do the proof with you before the final exam if they don't test it in trials. Okay, but don't worry about that. That's still a long way away. Okay, all right. I'm glad that everybody is happy with this. So now can you imagine if this geometric series that I've written in green on the board, imagine this series went on and on and on and on and on and on and on. It would take us forever to sit here going the sum to 100 terms and then 3 plus 6 plus 12 plus 24 plus 48 plus 96, we'd be here forever, wouldn't we? Okay, we want to be able to get to our answers quickly. And that's why we have formulae that allow us to get to our answers quickly. So that's what this formula is all about. It is the geometric sum formula. So the letters Sn represent the sum to n number of terms. So let's just clear a little bit of space here. Sn. Yes, somebody's got a question. There's a hand that went up. Whose hand is up?
So Katlego is the one talking now. Katlego, do you have a question?
Yes, ma'am. I just wanted to know the difference of the formula where it is a multiplied by 1 minus Rn, and then it's divided by 1 minus Rn.
Just say that again. I'm just wondering if you've maybe got confused with another formula. What formula are you talking about? Are you talking about this?
No, ma'am. When you like, oh, sorry, ma'am. No, I'm confused. I really am. I wanted to know the difference of the formula where you calculate the series, ma'am. Like,
so this is the formula for calculating series, because series means you are summing or adding the terms together. Okay, so this is your SN formula, your sum formula for series. Okay, specifically for a geometric series.
Oh, okay, ma'am. I know two formulas then, because like there is one exactly like this. It's just that you swap.
Oh, it's the other way around. Yes,
yes,
that's absolutely correct. So it doesn't matter whether you use this one or that one. All right. This one is the one that's on your formula sheet. So I don't know about your teachers at school, but I never worry about teaching the other formula. I just work with this one. Okay. But it means exactly the same thing. Okay. It does exactly the same job. It means exactly the same thing. Okay, so don't worry about where it's 1 minus Rn over 1 minus R. All right, we can just work with this formula. Okay, that's it, Lorato, quite right. Okay, so where were we? We were talking about what the different parts represent. So Sn represents the sum to n number of terms. So what I'm going to do is I'm just going to rub all of this off, and I'm just going to write here what this means. So sum to n number of terms. So Sn means sum to n number of terms. Miss Cindy, I see you've got a question. You go for it, Miss Cindy. Okay, Miss Cindy, I'm going to carry on, and then if you want to speak, you're more than welcome to unmute, okay? A represents the first term in the series. Yes.
How do you prove this formula?
You don't need to worry about that now. Okay, it's something that your teacher will teach you towards the end of the year. Don't worry about it now. Okay, it's not very straightforward, and it doesn't get asked very often. Okay, so I really wouldn't worry about it right now. Okay.
Okay, thank you.
No problem. All right, so that is your constant ratio. And n is the number of terms in the series. Okay, so that's what all these different parts mean. What I want to do now is I want to show you how to use the SN formula to calculate the sum to n number of terms, right? So the first example that we're going to have a look at, let's just go down here, is example number 24. Okay, so here the question asks us to find the sum of the first 12 terms of the series, 2 over 3. Guys, please mute if you are not talking to me or to Yolanda. Thank you. There we go. All right. So the first thing that we always need to establish matrix is whether we are working with an arithmetic sum or whether we are working with a geometric sum. This particular question, because I'm doing it in a lesson called geometric sum formula, obviously it's a geometric sum, but it's not going to be obvious to you when you're writing tests and exams. So in a test, your teacher could give you a question, or an exam, they could give you a question that says exactly this: determine the sum of the first 12 terms of this particular series, and they give you the first 3 terms. You have to be able to look at the terms and decide whether the pattern or the series is arithmetic or geometric. Okay, that's really important. When we look at these, we can see that 2 minus 2 over 3 is not the same as 6 over 2. But if we say 6 over 2, all right, we would get 6 divided by 2, we would get 3 over 2. If we say 2 divided by 2 over 3, we would get 3 over 2. So we can see that there is a constant ratio, not a constant difference. So that's really important. That's the first thing that you need to establish. Somebody had a hand up, which I missed.
Nkululeko still has their hands up.
Sorry, Nkululeko, go for it.
Nkululeko, you'll have to unmute on your side so we can hear you. So just press the unmute button and then you can talk to us. There we go.
Okay, ma'am, I'm confused because my teacher told me that 10 stand for position of the time in geometrical series, but then you say it stands for number of terms. So I'm confused.
It means exactly the same thing. All right, so n is the position of the term in the pattern. All right, and in this situation over here, n also represent the number of terms in the pattern. So it's the same thing.
Oh, okay.
It's the same thing. It's exactly the same thing. Okay. So in this question over here, they have told us that there are 12 terms in this particular pattern. All right. We don't know what the 12th term is. We know what the first term is. We know what the second term is. We know what the third term is. So in this situation over here, this question is asking us to calculate Sn. They are telling us that n is equal to 12. Now, in our formula, we also need A and we also need R. What is A equal to? A is equal to, you can pop it into the chat. A is equal to?
2 over 3.
That's it. Beautiful. What is R equal to? I think someone put it into the chat already. R is equal
3.
to? That's it.
3.
Lovely. Well done. 3. Okay, so now I've got A, I've got R, I've got N. It means I can sub in and I can calculate Sn. So this is how I set it out. I set it out as follows. The sum to 12 terms is A is 2 over 3. bracket. R is 3 to the power of n. N in this case is 12 minus 1 all over r minus 1. So that will be 3 minus 1 in the denominator. Okay, how did we find 3? Remember, you calculate your ratio by saying term 2 divided by term 1, or term 3 divided by term 2. So in this case, it's easy to work out the ratio because you can say 6 divided by 2.
Nkululeko's
Okay,
hand is up.
us
I'm not
3.
sure if that's a new question.
Okay, Nkululeko, what did you want to ask?
Nkululeko, you'll have to unmute yourself so you can talk to us, okay?
Right, I'm going to continue. In Nkululeko, if you want to ask, you're very, very welcome. So now we're going to put this into our calculators exactly as you see it on the screen. So I want all of you to do that. And then I want you to tell me what your answer is. You can pop it into the chat. You can press the SD button and round your answer to two decimal places. Sinelizwe, I think I pronounced that correctly. I don't know. You've got a question. You're welcome to unmute and ask.
Yes, ma'am. What did you get? R is equal to 3. What did you get that?
Okay, so I explained that over here. No problem. Okay, remember you calculate R by taking term 3 and dividing it by term 2. Or if you want to, you can take term 2 and divide it by term 1. So it's easier to divide 6 by 2 than to divide 2 by 2 over 3. So I'm just making life easy for myself and saying 6 divided by 2 gives me 3. All right, so those of you that are putting the answer 177, 146, 67, that's perfect. Okay, good job. Well done, everybody. That means that you are competent at being able to sub into the SN formula and calculate the value to S number of terms. All right, good stuff. Well done. Let's go and have a look at some questions that you can try on your own. So either you're going to do 1A or you can do 1B. B is a little bit more difficult than A, and they've also told you the number of terms in the particular series. So off you go, you can work that out. And of course, if you've got any questions, you can ask Yolanda and I to help you.
Yeah, and you guys are doing really well, especially if this is your
Very
first
well.
time seeing it. Yeah, Sandra, do you have any question? Can I unmute?
Yes, I do. Excuse me, Miss. The sum that you just explained right now, like, I didn't even actually, I don't know how to put everything in the calculator. Obviously, my calculator is it doesn't work properly. So would you just please show me how you put everything in the calculator and it gives you like the whole full answer, please?
Okay, I have downloaded an emulator program, which I actually need to put in so I can show you what it is that I'm doing on the calculator. But essentially the idea is, I just want to leave this question here so that people can continue to work on that. Okay, so the idea is what you would need to do is you would need to practice, you would need to press your fraction button, your button that looks like this. Okay, and then what you need to do is you need to use there's a round button where you can choose whether you want to go up, down, left, right, whatever the case is. Go up and make sure that you are sitting in this block over here and press the fraction button again. And what will happen is that it'll give you something like this. Then you can go and you can put the 2 at the top here and the 3 over there, and then you're going to use brackets. All right, and then you could put 3 to the power of 12 or whatever it was, minus 1, close your brackets. This line will obviously be extended over here, and then now here at the bottom, that block will actually be over there now, and you can go and put in your 3 minus 1 or whatever it is at the bottom. Okay, that's how you would use your calculator. Does that make sense?
Yes, it does, Miss. Thank you.
Okay, no problem. All right, sorry guys, there are the questions. Okay, Shobi, you are on fire this evening.
What I found helpful, guys, my pips, just take a screenshot. Do you see now that you have these questions? What's helpful is to take a screenshot, just in case you never know, because of the pace of how you're working. So take a screenshot and try to work it nicely in your own pace.
Absolutely. If you are a fast finisher, you're welcome to try the second question as well.
You guys are doing really, really well. So proud of you. Let's go.
Okay, good stuff. Well done, Sihawu. SN stands for the sum to n number of terms. So the sum to 9 terms. Okay, so as far as the rest of you are concerned, or as most of you are concerned, the first answer that a lot of you have put into the chat looks good. Good job. I'm also getting 728.96. Okay, Tsegofatso, okay, so you don't need to worry about getting n in this case. N is given to you because they told you that there are 9 terms. So they're implying that n is equal to 9. Okay, let's check the answer for B as well. Okay, so this is the sum to 10 terms. They tell us that there are 10 terms in this series. Okay, so A is negative 64. R is equal to, you should have got negative 1 over 2 as your R value. That's got to be raised to the power of 10 minus 1 over. All right, so you would have gone and subbed that in. Let's just double check. Okay. Let's just have a look at your answers. Yes, there we go. All right, so I'm also getting negative 42.63 as the answer for that. All right, absolutely. So when we are subbing into a formula, remember we can only solve for one unknown. So we've got 4 variables. We've got SN, N, A, and R. Okay, so if they want us to calculate SN, we need to know N and A and R, don't we? Okay, because we can only solve for one unknown in an equation. See how you got 1 over 4 for what? What did you get 1 over 4 for as your answer? Oh, see how I see this. Sorry, I just looked up. So, ma'am, how did we get the half? Okay, so remember that is your R value. How do you calculate the value of R? R is term 3 divided by term 2, or term 2 divided by term 1. So if I take negative 16 and I divide it by 32, that's where I get minus 1 over 2 from. Or if I take positive 32 and I divide it by negative 64, I'd also get negative 1 over 2. Okay. Yes, good advice there, Yolanda. Be careful when you round, make sure that it is exactly to 2 decimal places. Khomotso, I wonder why you got minus 42,71. Yeah, Shailene, that's interesting. Shailene, did you put in, and Khomotso, did you put in exactly what we've got here on the calculator? I wonder how you could be off. Timberlake, go for it. Yes, Sihawu. They can have addition or they can have subtraction. Correct. Yes, hello. What's your question?
Yes, ma'am. My question is, what if you're not given the term? Then what do we do if you're not given
Okay,
the
so then you might have to use the TN formula to calculate the number of terms. And I've got an example like that just below here that we're going to do together.
Okay, thanks, ma'am.
Okay, so I'm going to show you how you would do it in this case. Okay, this is exactly it. All right, so how would we find the sum when the number of terms is not known at first? Okay, let's just move these things and make that a little bit bigger for you. Oh, how I would have put it into the calculator. Okay, so I would have put it into the calculator. Which question are you talking about, Shailene? The second one, question B.
Yes, ma'am, B.
Okay, all right. So it would be the same idea where you would press the fraction button on the calculator. Then when you're sitting at the top here, that's when you would put in minus 64. Then you'd put in a bracket. Then you'd put in another bracket. Then you could either use negative 0,5, or you could press the fraction button again and put in minus 1 over 2. But you've got to remember to put brackets around it. And then you've got to raise it to the power of 10. Remember, when we substitute using brackets, exponents go on the outside. Minus 1. Now, because I opened 2 brackets, I've closed one, so now I must close another bracket on the calculator. All over. And then this number at the bottom over here will now be in the middle. Again, I'm going to press the fraction button and I'm going to put in minus 1 over 2. And then I'm going to press minus 1 like that. That's what I would do on the calculator.
Yeah.
Okay, and then you should get exactly the same answer that I do.
Okay, Mama, I got it. I didn't put 2 brackets. That's why.
Okay, yeah, so if you open a bracket, you've got to make sure that you close a bracket. Otherwise, your calculator will tell you that there is a math error. Okay. All right, so let's go and have a look at this next example. Are we all good with that? Sorry. Is there a thumbs up? Is everybody fine, happy? Sorry, I just moved on to the next question.
My people look like they are fine. Well done,
Okay,
everyone.
good. Well
Yeah,
done,
doing
everybody.
awesome.
Especially those of you that haven't even done this at school. If you're getting it right, then that's awesome. Good job. Okay. Oh, good. Nice, everybody. Well done. That's lovely. That's really positive feedback. Thank you. Okay, so I can't remember the name. Sorry, you did ask a very good question. Somebody asked, well, what happens if we don't know the number of terms? So now they give us this particular situation where they ask us to calculate the sum of the following finite series. What does the word finite mean, by the way? What does the word finite mean?
It has an end.
It ends. Okay, so quite right. It needs to end. It ends somewhere. right? So the following finite series, 0,25 plus 0,5 plus 1 plus 2 plus da, 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 plus 256. What can I say about 256 in this question? What does it represent for us? What is
The last term of the
256?
sequence.
It's the last term.
Well done. It is the last term. Absolutely. It is the nth term of the pattern. All right. So 256 is the nth or last term. Nth or last term. If we now sub into our SN formula, this is what we're trying to calculate because the question says calculate the sum. We've got A is our first term. We can work out what R is by saying term 2 divided by term 1 or term 3 divided by term 2. But N is also unknown. We do not know the number of terms. So we cannot solve for two unknowns in one equation. So I cannot use the SN formula in this situation, first of all, because both SN and N are unknown. That's why I have to use my nth term formula for a geometric series to first calculate the number of terms in the series. Okay, so I'm going to use my Tn formula to calculate the number of terms in the series, because both the number of terms in the series as well as the sum of the series is unknown. Okay, so now let's just double check. Okay, so Pinga says that there are 11 terms. Pinga, you are possibly correct. We will do that now. You could welcome to go on and do the rest of the sum, Pinga, if you've got everything else correct. Stembile, you've got a question. You're welcome to unmute.
I think Stembile is experiencing some audio problem. I'm not sure if Stembile can hear, but you will have to log out and in again because you did hear us before. So either it's network or something.
Okay, so a lot of you are saying 11 terms, so that means you can do this, because we did talk about this not the last time I saw you, but the previous Tuesday. So A is equal to 0,25. R in this case is equal to 2 to the power of n minus 1. So we would have to take 256 divided by 0.25. That gives us 1024 equals 2 to the power of n minus 1. This is 2 to the power of 10 equals 2 to the power of n minus 1. And if n minus 1 is 10, then n is equal to 11. Yes, well done, guys. That's brilliant. No, Naledi. That formula is for arithmetic. Okay, it's not for geometric. Well done. And then you guys are working out what SN is. So now that we know what N is, we can now sub in. Mokhawa, I see you've got your hand up. You're welcome to unmute and ask.
Ma'am, why are we using the TN formula instead of the SN formula?
Because both N and SN are unknown in the SN formula. So you can't solve for two unknowns in one formula.
Okay.
Okay, so we have to use the TN formula in this case to calculate the number of terms in the series first. And once we know the number of terms in the series first, then we can use the SN formula.
Thank you, ma'am.
Okay, no problem. So A was equal to 0.25. Bracket R we said was equal to 2 in this case. So 2 to the power of n, which we now know is 11. Minus 1, and then at the bottom, we've got 2 minus 1, like so. All right, so we're subbing into our SN formula. You guys can share your answers in the chat.
Remember to take screenshots like this. You can reference, always take screenshots. I see you, Minentle. Well done. I see the focus in you.
Okay, let's see what your answers are. That's it. I'm getting the same thing.
I think
Okay.
Sinelisi has a question also.
Sure, Sinelisi, unmute yourself and please go ahead and ask.
Ma'am, where did you find 11?
Where did I find 11? Remember, I used my TN formula over here, to first calculate the number of terms in the series because I didn't know how many terms there are in the series. Because I can't solve for two unknowns. I can't solve for Sn and for N using one formula. Good question, Masejo. All right. This sort of question would carry marks, a mark for subbing in here, a mark for making the bases the same, a mark for your answer. Then there'd be a mark for subbing in here and a mark for your answer over there. All right. So that's what it would be for. Yeah, I like to try and show you, Mark. Should you also do number 3? Yes, all way to. So that's your opportunity to practice. Go for it. Because Khomotso, that SN formula is for an arithmetic series. We are talking about a geometric series. So you can't apply an arithmetic series formula to a geometric series. No worries, Shane. Sorry you missed some of this. At least it's being recorded. The recording will be up tomorrow. You'll be able to go and watch and at least see what it is that you've missed. Okay, so we've got the first part. All right, good. Keep going. Please stay on mute unless you're asking a question so that it doesn't disturb anybody. Okay, yes, absolutely. So a lot of you have shared that n was equal to 12. Okay, Senolo, did you maybe just make a little typo there? N was equal to 12. A is the first term of the series, Ayanda. So A is equal to minus 64. Okay, so A is the first term. There we go. Good, Timbani. Well done. Good, Michaela. All right, and now we're going to sub into our SN formula. So our sum to 12 terms. All right, so I see there are questions. You're welcome to go ahead and unmute and ask. What's your question?
Ma'am, where did we get the 2004?
The 2004 and 48, sorry.
And
Is that what you're
48.
asking? Okay. So it comes from us solving the equation. So in other words, I want to isolate the base. So I need to divide both sides by the number that's in front of the half. Okay, so what I did on my calculator.
Sorry, Leah, I can't find the person who's talking. Hello, everyone. Can you please unmute? So if you are not talking to us, please unmute because we cannot hear teacher Leah. Okay. Thank you so much. Remember to stay muted as long as you're not talking. Please mute yourself because we can hear the background and it's not nice to hear. Thank you.
Thank you, Yolanda. Okay, so we've divided both sides of our equation by negative 64. So if we take negative 1 over 32 and we divide it by negative 64, that's where we get the 1 over 2048 from. Okay. All right, it's a pleasure. No problem. All right, and then as with many of you, I think I'm getting the same answer that you guys are. We pop that into our calculator. I'm getting minus 127, 97. Okay, so just remember to round correctly to 2 decimal places. Lovely. Okay, so now this is what you need to do, okay? You can't prime a fraction. So you're going to only put in the denominator. So you're going to press 2048 on the calculator equals shift fact. And then your calculator will tell you that the answer is 2 to the power of 11. But you know that you've got to write 1 over 2048 as 1 over 2 to the power of 11. Okay, so that's how you would do it. All right, so there are a few people with hands up. No problem, Ayanda. Let's just help the people with their hands up. Okay, Sinaliswi, your hand is up first. Go for it.
Sorry, ma'am, I didn't raise a hand.
I beg your pardon? I think she said she didn't mean to raise her hand. Okay. Olwetu, what's your question? Olwetu, what's your question?
No, I already asked the question. You answered me.
Okay. All right. That's fine. Katleho, do you have a question?
Ma'am, I just wanted to know how, ma'am, what if you multiply before you divide?
In what respect are you speaking, Katleho? Where would you multiply before you divide? You mean the negative 64 by a half?
Yes, ma'am.
Okay, you're not allowed to do that because then you're breaking the mathematical laws. Because there's an exponent on the half. So remember, in maths, you can't multiply a number that has a different exponent to your base and then keep your exponent, because that's not a rule. Okay, so that would be breaking a mathematical rule.
Okay, ma'am, thank you.
Okay, so you're not allowed to do that. Mukhao, what's your question?
Ma'am, can we write it as fractions instead of -127?
Where did we not write it as, where did we, you mean the answer? Yes, absolutely.
Yes.
You could write it as an improper fraction or a fraction, not a problem at all. It means the same thing.
Okay, thank you, ma'am.
Okay, no problem. Tsegofatso, what's your question?
I'm getting -10 for n.
For A is the first, for N, -10. Okay, so now that cannot be. So this is how we calculated N, right? Was this bit over here that I'm just putting a red line around. Can you compare that to your answer and maybe see where you've gone wrong?
I can't, ma'am, because like I converted my 1/2, like I made it 2 to the power of -1, and then the 1/2 2000 to the 2048, I converted it to 2048 to the power -1.
So if you were gonna write 1/2048, all right, you would have to write that as as 2 to the power of -11.
Oh, okay.
Okay, all right, then that would work. And then on the other side, you'd have 2 to the power of -n plus 1. Okay, and then that will work because now you've got -n plus 1 equals -11. So then -n would be equal to -12. So then n would be equal to 12. You can do it like that. Okay.
You see my mistake, ma'am. Thank you.
Okay, no problem. All right, let's just see who else had a hand up. Sandra, go for it, Sandra.
Miss, the only way that I'm really confused, it's like we have this formula which you have written at Tn is equal to ARN minus 1. While in class today I just like have another formula which is Tn is equal to A plus open bracket n minus 1 close bracket t. So can you use the same formula as this one, the one that we're learning here?
No, Sandra, you can't, because this formula over here is for an arithmetic pattern. And in today's lesson at Watobe, we're not talking about arithmetic patterns, we are talking about geometric patterns. Okay,
so in exams, if the topic of geometry, should you use all this kind of formulas here?
Absolutely. So what you're going to find by the end of it is that you're going to end up with 5 formulae. You're going to end up with Tn equals A plus n minus 1d, and you're going to end up with Sn equals n over 2 2a plus n minus 1d. Then you're going to have Tn equals AR to the n minus 1, and you're going to have Sn equals A R to the n minus 1 over R minus 1. And then the 5th formula is your sum to infinity formula. Okay, so there are 5 formulae in this particular section. Okay, so number one belongs to arithmetic sequences. So this is arithmetic sequences. This one over here, number 2, is arithmetic series or summing. This is geometric sequences. This is geometric summing. And this over here is your sum to infinity. Okay, so you've got to use the correct formula for the question. All right, now I see there's a whole bunch of hands that have gone up as well. Sandra, does that answer your question?
Yeah, thank you.
Okay, all right, no problem. David, what's your question?
Oh, hi, ma'am.
Hi there.
Okay, ma'am, what I wanted to ask, okay, you're gonna use these formulas in the exams. Okay, as for the questions, are they gonna be those type of questions that say, prove that it's a arithmetic series and geometric series?
They could do, David, but they're not very common. Those sort of proofs are not asked very frequently in NSC papers. You see them sometimes in the supplementary papers, but I haven't seen one in a government NSC paper actually since 2014, since CAP started. I'm not saying that they won't do it. We never know what they're going to do at the end of the year, but it seems very unlikely. All right, so there are proofs which your teacher should show you, but I really, really wouldn't worry about it at this stage. Okay, David?
Okay, thank you, ma'am.
No problem, it's a pleasure. And then Shailene, you had a hand up, go for it.
No, ma'am. I want to ask the same question that he asked.
Oh, okay, all right, no problem. Timberlake?
So, ma'am, today in class we did geometric sequence. What is this? Yeah, sequence. What if, ma'am, you have to find x and y?
When you say x and y, what do you mean? Are you talking about in a quadratic pattern, or are you talking about in these sort of sequences?
In geometric.
So you need to give me an example. So you need to give me an example of a question that you're thinking about.
Okay. The first term of a geometric sequence 7, x, y, 56. Determine the values of x and y.
So, all right, what I'm going to ask you to do is I'm going to ask you to email that to me, okay? My email is lee@watobe.com, okay? Because that sounds like a problem-solving question, right? I'm more than happy to do that with you, but email it to me. That's fine. I'll do it with you, and we'll do it at the start of the next lesson. Okay, but I'm not going to be able to do that right now. Okay, but I will definitely do it. Email it to me, no problem.
Okay, ma'am.
Yes, absolutely, Nosipo. We are going to do questions from past papers. That is the idea. Okay, absolutely no problem. All right, we just haven't done it yet, but we're going to. Rona, there was also a question.
Yes, I wanted to ask if she could send the question in the chat so that some of us can also have a look at it.
Oh, absolutely. I wonder if she could do that. Yolanda, is that possible?
No, actually, no, I don't think so. So we'll have to share it with them on Thursday when Teacher Leah has already gotten it, so you can share screenshots.
All right. Sorry, Rona. There are loads of problem-solving questions that I can show you guys and I can do with you. And that is definitely part of the plan. It always is at Watobe. So I always do exam questions. All right. Obviously, we're just not quite there yet because we haven't done all the different bits and pieces yet. Nolutando, what's your question?
Hi, ma'am. I just wanted to know what's the topic of the sequences and series?
We are going to be doing geometry.
Okay, thank you, ma'am.
Yes, no problem.
Can I ask a question, ma'am?
Yes, of course you can, Rona.
So after this topic, we're done. So we're not going to do sigma notation.
No, I can do sigma notation with you. I was going to do the sum to infinity, but would you prefer me to do sigma notation?
Yes, please.
Okay, all right, then I'm sure that's fine. I'm sure it's okay if I go back and I go and change what it was that I had scheduled. I'm sure that's not a problem because I know sigma notation does confuse a lot of people. So I'm more than happy to do that.
Okay, thank you.
Okay, sorry, I actually wanted to get to sigma notation. You can see it's down. Where is it? It's down there, but I just didn't quite get that far this particular lesson, but that was actually my plan. Okay. All right, I see there's some more questions. Let's just take those. Noluthando. Okay, Katleho.
Ma'am, this is like a question for everyone, ma'am, not necessarily you. I just wanted to know, ma'am, is it okay if I like start a group chat, a WhatsApp group chat, so that like maybe we can help each other out, because I'm an online learner and I don't really get to like what's that, connect with people a lot. So it would really be useful for me, and I think other online learners, if we like connect and help each other out with math. And I will share the link next week, ma'am. This is a question for everyone. I don't know if that's a good idea or a bad idea.
Okay, see, the only problem with something like that, Katleho, is that the company Watobe cannot take responsibility for what gets shared on a WhatsApp group. So there are certain laws that mean that we are not allowed to share information in South Africa. It's a new law that came out a couple of years ago called the Poppy Act. And it's very, very strict in terms of the information that we can share about other people in a public space. Let me first go and check with the people that own and run Watobe and just see what it is that they have to say. But I'm not sure that Watobe would be able to host something like that. But as I say, I'll come back to you. Let me speak to them and I'll let you know. All right.
Okay, ma'am. Thank you, ma'am.
All right, no problem. There's the poll. Please answer it. If you've got any other questions, we can chat afterwards. Please do the poll.
Let's do the poll, everyone. Y'all did really, really good. Remember, for those that are really choosing fast, okay, or way too fast, there is a class that actually starts at 5 until 6. Then that class is a little bit slower. So you are allowed to submit your name either to Teacher Leah or to myself next week, Thursday, when you have thought about it, so that we can put you on the foundation class, okay? So you're allowed to do that if you think this class is way too fast for you. But you guys really did well. So I just need every one of you to actually vote. It's 100%. I'm not sure if Ramaisela, is that a question for Teacher Leah before Teacher Leah goes? You have a question? Do you want to unmute and ask? Ramaisela, have a question?
Ma'am.
Yes.
Like I just wanted to tell Ma'am Leah that we did that one of X and Y already.
The one that the other student was asking about?
Yeah, yes.
Okay. Well, she's going to email it to me. I'll start off next lesson doing that. And then we will go ahead and go and do the sigma notation. All right. So it's all right if you've already done it. I think it'll be good for you to see it again.
Okay, Ma'am.
Okay. Thank you, everybody.
I haven't taken my screenshot, so before we go, let me
Okay,
just
all
take
right.
my screenshots.
Okay. Oh, good. And we had 84 people answer the poll, which was great.
Yes, well done, everyone.
Well
Even
done,
though we're many of
everybody.
us,
Thank you.
but
Well
I'm proud of
done.
you. Yeah.
Oh, sorry.
you, Teacher Leah.
iPhone, you've already finished this topic. You're currently busy with functions. When we'll be busy for pleasure, Anele. I'm not 100% sure. I'll have to go and check. All right, iPhone. I'm not sure when the plan is to do. From what I can see, that doesn't seem to be in the first term schedule, but I can ask about it. Okay, iPhone. So. And then
Okay, bye-bye to everyone. Thank you, Teacher
Bye-bye,
Leah.
everybody. It's a pleasure.
Bye. Thank you.
Bye, everybody. It's a pleasure. Minashra, I don't know. I will double check on that and I will get back to you guys in the next lesson. Okay, it's a pleasure, everybody. Enjoy your evening.
Yeah. So we
Bye.
got a lot to now walk out lost.
Thank you, Marina. Pleasure, Marsha.
Hello.
Pleasure always too.
I didn't hear you.
Hello?
Hi.
Hi, who's talking?
Renewa.
Okay, do you have a question you want to ask us?
I don't know, but ever since they started teaching us the geometric series, determining the formulas and the arithmetic, I haven't had anything like it's so difficult for me to solve questions.
Okay, so I think the idea is, I know if you find that this class is a little bit too fast for you, you're welcome to join the class that we have from 5 to 6, because there what I'm going to do is I go much slower through all the questions. All right, and it's sort of slightly different to this class. This class is the sort of faster class. So maybe it's better for you to attend that one where the pace is a little bit slower and I'm explaining a lot more.
The problem is that I come back home at 7 o'clock. Like I just came home.
Oh,
back
wow.
home now.
Oh, wow. Okay. So if you only get back home at 7, this class starts at 6. So that means that you're going to miss out on the beginning bit. But what you can do is you can watch the videos.
Oh,
And that should be, so the videos get uploaded 24 hours after the lesson. And then you can go there and you can watch the video from start to finish where I work through all the questions and I explain what we're doing. That might be an option for you. But unfortunately, yeah, we run our lessons from 5 to 6 is the one class, and then 6 to 7 is the second class.
Oh, okay, I understand.
Okay, so maybe just talk to your parents and just see what you can organize with them. Okay.
Okay.
All right. Okay, my darling. Khomotso, yes, I'm going to speak to them about that and see what we can do about extra practice or work or what I'm allowed to do or can do. Okay.
Okay. Sorry. Can I ask?
Yes, go for it.
Let's say that we were given the infinity and also the R on a, in a pattern. Then they asked us to find the A. So how are we going to find the A when we were only given the infinity and also the R?
Okay, so then what you would have to do is you'd have to sub into the sum to infinity formula. Okay, so it's hidden at the moment by the pole. But if you knew what the sum to infinity was for the particular series, you would sub that in here. If you know what R is, you would sub that in here. Then that means that A is your only unknown. So then you could solve for A.
Okay.
Okay, like that. Okay. All right.
Yes.
I find it also difficult to separate the two formulas. That one that you wrote up there on number 4 and also number 2.
Yes, so you have to learn these. So you have to learn that the Sn equals n over 2 formula is for arithmetic series, and that this formula over here, number 4, is for geometric series. Okay, so you just have to learn that.
On the arithmetic series, when we are determining the sum, if we were given the last term.
Yes, you can also use that formula. It's not on your formula sheet, but it's this formula over here. So it's n over 2 a plus l. You can also use that, okay, in arithmetic series. Okay,
yeah.
But that's not on your formula sheet, okay?
Okay.
All right, but yes, you can use that for arithmetic series as well if you know the last term.
So have you done the sigma notation?
There was some sigma notation that was done last week. I didn't get a chance to do any sigma notation this week, so I'm going to try and do sigma notation with you next week.
All right, no problem.
Okay, or next time, should I say, not next week.